alkanes. It is based on stereochemistry and free radical substitution reactions. So initially 2,3 dichlorobutane is given meso compound. It is optically inactive. You can see there is plane of symmetry, internal compensation. It is subjected to monochlorination that gives trichloro products, and the mixture of trichloro products, that mixture is subjected to fractional distillation. You will get x number of fractions, and he is asking what is the value of x. And in order to solve this question, let us take all structural possibilities first. So here this is a CH3, this is a CH3, chlorine, chlorine, hydrogen, hydrogen. But here stereochemistry is clearly mentioned. So this is a chiral carbon, and this chiral carbon has S configuration. This is also chiral carbon. It has a R configuration. And if you see positional wise, you can start numbering from this side or this side, because if you start from this side, position of chlorine 2 and 3. If you start from this side, positions of chlorine again 2 and 3. But stereochemistry is fixed. You start either from this or from this. Least locant rule says the numbering is the same. But according to IUPAC, when least locant rule is same from both the ends, R should always get more priority when compared to S. Based on that, this is the first carbon, this is the second carbon, this is third carbon, and this is fourth carbon. Now, if you see the stereochemistry at a second carbon, it is 2R. At a third carbon, it is 3S, 2R, 3S, 2, 3, dichlorobutane, butane. Now, I am taking substitution at this carbon. As a result, from this I am taking at a first carbon. I am taking substitution at a first carbon. As a result, it becomes a CH2Cl, and this is a CH3, H, H. Now there is no plane of symmetry. This is optically active, so this molecule is chiral. And another possibility, instead of taking substitution at this carbon, now I am taking at this carbon. As a result, it becomes a CH2Cl, and this is a CH3, Cl, Cl, hydrogen, and hydrogen. In fact, these are structurally same, but stereochemistry wise, they are definitely not same, and we'll prove that this is also chiral. And here the configuration of this carbon and this carbon will not be affected because of chlorine. That is very clear. And if you see the stereochemistry at this carbon, again the configuration is R. Here the configuration is S, and here the configuration is S, and here the configuration is R. But now we have to give the numbering based on least locant rule. So here the numbering of the compound, if you see, this is the first carbon, this is the second carbon, this is third carbon, this is fourth carbon, and this compound is 2R, 3S, 1, 2, 3 trichlorobutane. And if you see the IUPAC name of this compound, so here this is the first carbon, this is second carbon, third and fourth, least locant rule. I took least locant rule into consideration. And this particular compound is 2S, 3R, 1, 2, 3 trichlorobutane. Now, if you see, they are definitely not same. You can see this is 2R3S and this is 2S3R. Configuration is exactly opposite at both the chiral centers here in two molecules. Therefore, this mixture is enantiomeric mixture. This is a enantiomeric mixture, and these two are not same. These two are enantiomers. They are not identical. So you may be confused with the 1 comma 2 comma 3, 1 comma 2 comma 3, but stereochemistry, if you see, they are not identical. They are enantiomers. We have two compounds. Now the next one, again I am taking the starting compound. So here this is chlorine, this is chlorine, CH3, CH3, and of course remaining are hydrogens. This is with S configuration, this is with R configuration. Now let us take the substitution at a chiral carbon, but very clear, this carbon has R configuration, this carbon has S configuration. From this I am going to get two more products. I am taking substitution at a second carbon. At a second carbon, as a result, it becomes a chlorine, chlorine. Of course, this is chlorine and hydrogen with retention of configuration. And here this is CH3. Now this is not chiral. Only this is chiral, and the configuration is S. This is optically active and the configuration is S. And the numbering, if you see, this is first carbon, second carbon, third carbon, and fourth carbon. This is 3s. 3s, 1 comma, not 1 comma, sorry. This is 2 comma, 2 comma, 3 trichlorobutane. If you see the substitution at third carbon, the product will become like this. So this is chlorine, this is chlorine, CH3, chlorine, hydrogen, and CH3, least locant rule. So the numbering will be like this. Now again third carbon is chiral, but this is 3R, 3R, 2 comma 2 comma 3 trichlorobutane. So totally we are getting four products here. Totally we are getting four products. So here this is the first one, this is the second one, this is the third one, and this is the fourth one. So here the total number of products, trichloro products 4. But if you see, these two compounds are enantiomers. These two compounds are also enantiomers. And we have totally four compounds, 1, 2, 3, and 4. These two compounds, enantiomers, they have same physical properties. They boil at a same temperature. 3 and 4 also, they are also enantiomers. They also have same boiling point. When this mixture is subjected to fractional distillation, since these two compounds are having same boiling point, they will be evaporating at the same temperature. So you will be getting fraction 1, that is having 1 and 2, and this is definitely different boiling point this pair is going to have, because the relation between any compound of this, any compound of this, they are diastereomers. But 3 and 4 are enantiomers, so you will be getting another fraction, that is 3 and 4. So ultimately you will get two fractions. So the answer is